We humans owe everything we are and everything we do to our bones. But did you know that compared to us, nature's miniature weightlifters like leafcutter ants and dung beetles can lift much heavier loads without even having bones? It's fascinating to think about. And it got me wondering, why did we end up with our skeletons on the inside instead of the outside? So, let's have a look into this. You are watching LectureIT. First off, let's take a moment to appreciate just how amazing bones are. We're built with about 206 of them, although some people have an extra pair of ribs or even one less. And did you know that our hands and feet have more than half the bones in our bodies? The rocks in your fingers were moved by muscles and nerves to help you click on this video, and the oxygen powering your brain is being fed by blood made in your bones. Even the tiny bones in your ears allow you to hear me talking right now. All of this from body parts that are about 70% mineral and made of an inorganic material called hydroxyapatite, which is stiff when compressed, combined with flexible protein called collagen to keep us from shattering. As a result, the 20 or so pounds of bones in the average body can withstand 1 ton of compression. That's pretty awesome, isn't it? But where did bones come from in the first place? The story goes back at least 1.5 billion years, to a time before animals even existed. Violently shifting tectonic plates were washing tons of minerals into ancient oceans, and these minerals would one day become skeletons. Life stayed pretty squishy for a while, but around 558 million years ago, a happy accident of evolution caused life to split in two, and 2 different skeleton stories began. On one branch, strange creatures began to develop the first hard protective parts, the precursors of exoskeletons. This set off an arms race of armor, with newly shielded organisms surviving more than their squishy friends. Early exoskeletons got fancier, and we began to see animals with crushing mouth parts, pinchers, and full suits of armor. On the other branch, in squishy tadpole-like creatures, soft cartilage-like backrods began to form in order to provide scaffolding for muscles and movement. Soon, this hard stuff formed the basis for new structures like jaws. Later, this mineral armor was slowly internalized, and those early backbones became mineralized. Over time, this became the key part of the vertebrate skeleton as we know it. Now, you might be wondering why we didn't end up with exoskeletons like insects and crustaceans. After all, they're incredibly strong pound for pound. But like most things in nature, there are trade-offs. For starters, opting for an armored exterior skeleton makes growing more difficult. Every time a lobster or a cockroach is ready to size up, they have to molt, shedding their old skeleton and leaving them soft and vulnerable for days or weeks, while they wait for a new outer shell to harden. There's also a weight problem. The strength of an ant's legs works at its tiny mass, but scale that ant up to our size and it would be crushed under its own weight. On the other hand, our internal skeletons provide bigger attachments for muscles than exoskeletons would, and our bones grow with our muscles as we get bigger and stronger. But bulkier vertebrates have to have more massive bones, which can make them less agile. And let's not forget that a human-sized ant would suffocate since insects don't have blood like we do. So while exoskeletons are super strong, they come with their own set of limitations. It's a fascinating example of how different evolutionary paths can lead to different solutions for similar problems. And let's not forget that bones aren't unique to vertebrates. Invertebrates like mollusks, coral, and starfish also use calcium to build their support structures. It's just that insects and other arthropods went down a different path, building chitin exoskeletons instead of internal bones. Who knows, if we played the story of evolution back from the beginning, perhaps our line would be built differently too. But one thing's for sure, we wouldn't be as big as we are now. In the end, bones are an incredible adaptation that allow us to do amazing things. From lifting heavy weights to running marathons, our bones make it all possible. And it's all thanks to a chance event of evolution that led to the development of internal skeletons. So the next time you're feeling bone tired, just remember how amazing your skeletal system really is.